Hi, this should help you a little bit with the quiz that we're going to have tomorrow and to give you a bigger picture idea. So I'm just going to work a problem, but the problem's the most basic that you can get. For example, the most basic question you can get for finding the equation of a line is that you're given 2 points, and then you have to compute and get the slope and the y-intercept. So the most basic problem you can get for a plane is that you're given 3 points, and you have to find the normal vector and a point on that plane using those 3 points. Okay, so here's an example. Find the equation of a plane through these 3 points. The first thing to understand is I need 2 things for the equation of a plane. One is the normal vector to the plane, another is a point on the plane. So I can choose any one of them to be my point on the plane. So I'm just going to choose P0 to be 2, 1, 1. So I did the easy part first. How do I find the normal vector? Well, first, let me draw a schematic. And I actually had this a little backwards when I did the computation, heads up. If I label those points A, B, and C, they all lie on this plane. I can form vectors between those points. I know how to do that tail to head. Those are 2 vectors that lie on the plane, those 2 blue vectors. Now, to get a normal vector, I need one that's perpendicular to the plane. If I get a vector that's perpendicular to both of these vectors that lie on the plane, the AB and the BC, then I would have a vector sticking up. And I know how to do that. If I call U the vector between A and B, and V the vector between B and C, then U cross V is perpendicular to both U and V, that's the cross product, and therefore it's perpendicular to the plane. So I drew that in my schematic differently than what I have here. The vector AB, I had it going from B to A, but it doesn't matter because it all works out in the wash. So I can form the vector AB by tail to head, taking B and subtracting off A, and form the vector V, and then compute the cross product. By this time, you should definitely know how to compute a cross product. That gives me my normal vector. Now I have the ingredients for a plane. I have the normal vector and I have a point on the plane. Bake it. I take the dot product of the normal vector with x minus 2, y minus 1, z minus 1. Why am I doing that? Well, if this vector n is perpendicular to any vector on the plane, x, y, z is an arbitrary point on the plane. If I form the tail to head, this is a tail to head with my known point on the plane and an arbitrary point on the plane. If I subtract the 2, I get this vector that lies on the plane, and the dot product of these 2 things should be 0. That's the basic understanding. From there, everything falls in place. So I did the math here, and I get what is a 3-dimensional version of point-slope formula, basically. And from here on out, you can pose it any way that is asked for. For example, you can do high school algebra and change it to standard form. You can get the symmetric equations. All of them are the same amount of the different expressions, algebraic versions of what I have here. All right, so for more practice, just try one. Find the equation of a plane through these 3 points. And then realize that you could be given other information. So for example, what if I know the plane goes through 2 points and is perpendicular to this plane over here? How do I find the normal vector to my plane from this information? I did a problem from WebAssign that's like this. Go back and look at it and see if you can answer this question. And on tomorrow's quiz, I will ask you this kind of question, not to work out the problem, but just tell me in words how I would find that normal vector and why it geometrically is that way. All right, so good luck and send me any questions you might have.